Hello, I'd like to present you, this is the AMC1280 USB. That's a full 6-stop controller. This is how is it fully assembled. Right now I have it for 2 motors. Let me set it for 6, so you can see the whole 6 motors here. That's the digital inputs from the computer. That's the digital, the analog signals for positioning. This is the analog connections. You connect the position sensor for the motors. Each motor goes to one of the 3 cables. It's the signal, the sync plus 5 volt at the ground. It goes on up to 6 motors. And this is the digital pole switch modulation interface for all 6 motors that can be used for DC motors instead of AC. Now, to use the VFD inverters, you have to use the extension board, the 6-stop extension board that is right now connected on the digital ports here. It's numbered, so you can have the same connections on the other side on the board. Just the little extension cables. So the 4 cables you need to connect to the inverter from the extension board. For each motor you need 4 cables. That's one analog signal, that's for the speed. That's actually, you can see here, it's the motor 1 here. One ground connection, and on the other terminal this is for 2 connections for the direction. That's clockwise and counterclockwise for each pair. So this is for the motor 1, this first pair. So it's 2 cables here, 1 cable at the ground. It all together goes into the inverter. You can see here, this is for the speed, goes there. I jumped the number 3 and 4 there. That's so I can have the reference signal for the 0 speed on to ground. Then I connected the 2 directional ones, that is on X12 on slots 2 and 3. And then of course the ground there, and I used on X12 the position 4 for enable motor. So I can have a little switch that can enable and disable the motor from working. This is actually used like for safety reasons, but you can have it all the time connected short circuit, but it's better to have it with little switch so you can enable for each motor you want not to work. So you can leave the cables, direction cables and everything connected, and just have it to run or not to run. So you can see here that's connections for the safety switch. Okay, now I'll activate it. It has a little lock. Okay, so except those 4 cables, the 6-stop extension board, you need it needs a power supply. That's a 24 volt power supply that it's from Eurodrive. It's the same, like it was in the same package with the motor and the inverter. So it's on activated, and I'll start the simulation here. I assigned the acceleration to the motor, so it's just one axis just to see the acceleration up and down. start it. For the motor to know the position it has to stay, you need to connect on the output, align to the output sensor, position sensor. This one is by Technologies, I don't know if you can see it here, a 180-degree sensor. That's digital, that means that it's not like potentiometers. It's actually magnetic Hall effect, so it can measure exactly 180 degrees from fully up and fully down. Let me do a demonstration on the program, on the math setup. I'll make it go all the way down and all the way up. Okay. It goes here. You can see the RPM of the motor. Okay. Zero. So that's pretty much everything about the motor. It's nothing special. I have connected the line 1 at the neutral to power it, just one phase, 240 volt, and of course the ground. You can see I used just simple Ethernet cables as the connection I have. It's in the dry room, it's about 2 rooms away. I had to run an extension cable all around, and of course a little safety switch, circuit breaker. Okay, and of course the output for the motor. It has a 3-phase output that goes, as you can see here, into the case. That's a double cable, double wire cable, and that's a single one. I just used 3. That's pretty much it. I don't think I forgot something else. Okay, thanks for watching.